The James Webb Space Telescope has been in the news since it was launched on Christmas Day 2021. The Superstar Telescope has since unfolded the universe in a way no one expected. Only recently, it discovered 6 galaxies that existed only 500 million years after the Big Bang. Not just that, these galaxies are well-formed and contain more stars than today's galaxies like our Milky Way. These galaxies should not exist as they toy with our model of cosmology, making matters more uncomfortable for scientists. Researchers from the University of Minnesota have discovered that one of these galaxies is so bizarre that we might have to go back to the drawing board. Welcome to Lab 360. It's time to explore. The James Webb Space Telescope can collect about 10 times as much light as the Hubble Space Telescope and is much more sensitive at redder, longer wavelengths in the infrared spectrum. This allows scientists to access an entirely new window of data on the early universe. To understand the early universe, we need to go back in time to a point where time and space did not exist. According to the theory of cosmic inflation, the universe was born with the Big Bang as an unimaginably hot, dense point. When the universe was just 1/100th of a billionth of a trillionth of a trillionth of a second in age, it experienced an incredible burst of expansion known as inflation, during which space itself expanded faster than the speed of light. During this period, the universe doubled in size at least 90 times, going from subatomic size to golf ball size almost instantaneously. After that, the growth of the universe continued but at a slower rate. As space expanded, the universe cooled, and matter formed. Only 1 second after the Big Bang, the universe was filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. However, for the first 380,000 years or so, the universe was essentially too hot for light to shine. 380,000 years later, matter began to cool enough for atoms to form. However, after this point, the universe was plunged into darkness since no stars or any other bright objects had formed yet. Fast forward to 400 million years after the Big Bang, and we can see the universe beginning to come out of its dark ages. This period in the universe's evolution is called the Age of Reionization. During this phase, which lasted for more than 500 million years, the first stars and galaxies began to appear. Scientists thought galaxies began building up in the first billion years after the Big Bang and sort of reached adolescence at 1 to 2 billion years. However, the James Webb Space Telescope has found not 1 but 6 galaxies that were fully formed only 500 million years after the Big Bang, and that is a problem. Using first-of-their-kind observations from the James Webb Space Telescope, a University of Minnesota team looked more than 13 billion years into the past to discover a unique, minuscule galaxy that generated new stars at an extremely high rate for its size. The galaxy is one of the smallest ever discovered at this distance and could help astronomers learn more about galaxies that were present shortly after the universe came into existence. The galaxy's volume is roughly 1/1,000,000th of the Milky Way's, but we can see that it's still forming the same number of stars each year. The galaxies that existed when the universe was in its infancy are very different from what we see in the nearby universe now, explain scientists. Studying these galaxies could help us figure out how and when these first stars and galaxies emerged from within the universe's dark ages. Until then, it remains a mystery how the universe came into being. As days pass, more results of observations from JWST are revealing that the universe, especially at its early stage, was stranger than we imagined. Not only has Webb discovered these early galaxies, but it has also now found a black hole that is almost as old as the universe. Scientists have discovered what they believe to be the oldest known black hole in the universe, owing to the telescope's ultra-powerful sensors that captured this elusive entity. This supermassive black hole, which dwarfs our Sun by a staggering 10 million times, existed at the center of a galaxy 570 million years after the universe's inception. Time so remote it's difficult to fathom. To put it in perspective, the universe itself is estimated to be 13.7 billion years old. Observations collected through the James Webb Space Telescope have revealed an active supermassive black hole, 10 million times the mass of the Sun, one that is actively growing as it slurps up matter from the space around it just 570 million years after the Big Bang. This is the earliest growing supermassive black hole detected yet. Although scientists are hoping it won't remain the record holder for long, the black hole was found inside one of the earliest galaxies ever detected, previously known as EGSY 8, though since renamed CS1019. Its discovery could help with one of the biggest head-scratches of the early universe: how the black holes in the cosmic dawn grew to such large sizes in such a short amount of time. We found the most distant active galactic nucleus, AGN, and the most distant, earliest black hole we've ever found, said an astrophysicist associated with the finding. Scientists were initially looking at CS1019 as part of their work investigating light produced by star formation in the very early universe. This light, called Lyman alpha emission, is thought to be generated by the ionization of neutral hydrogen by star formation activity. The early universe was filled with a fog of neutral hydrogen, which prevented light from propagating. It was only after this hydrogen was ionized that light could stream freely. This period is known as the epoch of reionization. Understanding this epoch is crucial because it marks a significant phase in the evolution of the universe, but it remains one of the least understood eras in cosmic history. During this time, the first stars and galaxies formed and began to ionize the surrounding neutral hydrogen, allowing light to travel across space and making the universe transparent to radiation for the first time. This epoch is thought to have taken place within the first billion years after the Big Bang, which occurred approximately 13.8 billion years ago. Despite its importance, studying the epoch of reionization is incredibly challenging. Observing objects from this early period of the universe's history is difficult due to their vast distances and the faintness of their light. As the universe expands, the light from these distant objects is stretched or redshifted into the infrared part of the spectrum. This redshift makes them nearly invisible to telescopes that primarily observe visible light, like the Hubble Space Telescope. However, a few exceptionally bright galaxies from this period can still be detected and studied, offering valuable insights into the early universe. SE-109, for instance, is one of these rare objects discovered in data collected by the Hubble Space Telescope in 2015. CS1019 was initially identified as the earliest and most distant galaxy observed at the time. Its discovery provided a critical window into the conditions of the early universe and the formation of the first galaxies. The brightness of CS1019, despite its extreme distance, makes it an excellent target for further study. Galaxies like CS1019 stand out due to their relatively high luminosity, which means they emit more light than other galaxies from the same period. This brightness allows astronomers to study their properties in greater detail, even with the challenges posed by their vast distances and the redshifting of their light. The identification of CS1019 was a significant milestone in observational cosmology. It helped astronomers push the boundaries of our understanding of the early universe, revealing that galaxies had already formed and evolved to a considerable degree just a few 100 million years after the Big Bang. This discovery also highlighted the potential of using advanced telescopes like Hubble to explore the distant reaches of the universe, paving the way for even more detailed observations with next-generation instruments like the James Webb Space Telescope, JWST. The Hubble Space Telescope's capabilities allowed astronomers to confirm the existence of CS1019 and similar galaxies, but the detailed study of these objects remained elusive. The earliest light in the universe is so redshifted that only a powerful, dedicated infrared instrument like JWST can probe it effectively. JWST, launched in December 2021, is specifically designed to observe the infrared part of the spectrum, making it an ideal tool for studying the epoch of reionization and the early universe. When JWST began its mission, CS1019, the brightest of the Hubble galaxies from this epoch, was an obvious target for its instruments. The telescope observed the galaxy for just 1 hour, but the data it returned was incredibly rich. JWST's advanced sensors captured a detailed spectrum of the galaxy, providing astronomers with unprecedented information about its composition, structure, and star-forming activities. This wealth of data revealed new details about CS1019 and other early galaxies, offering insights into their formation and evolution during the universe's infancy. In analyzing the JWST data, astronomers discovered that CS1019 exhibited both the light from star formation and a broad emission feature typically associated with active galactic nuclei, AGN. This dual emission was unexpected, as galaxies in the early universe usually emit either light from AGN or light from star formation, but not both simultaneously. The presence of both types of emission in CS1019 suggests that the galaxy harbors a supermassive black hole that is actively growing by accreting matter. This finding has significant implications for our understanding of the early universe. It indicates that supermassive black holes could form and grow rapidly even in the first few 100 million years after the Big Bang. The discovery of such a black hole in CS1019 challenges existing theories about the formation and growth of black holes and galaxies in the early universe. It suggests that these processes may be more complex and intertwined than previously thought. Furthermore, the detailed study of CS1019 and similar galaxies can help astronomers piece together the timeline of the epoch of reionization. By examining the light from these galaxies, researchers can infer the state of the intergalactic medium at different times and determine when and how the reionization process occurred. This information is crucial for building a comprehensive picture of the universe's early history and the formation of its first structures. The discovery of CS1019 and its subsequent study using JWST underscore the importance of advanced telescopes in exploring the distant universe. These instruments provide the necessary capabilities to observe the faint, redshifted light from the earliest galaxies, allowing astronomers to uncover new details about the universe's infancy. As JWST continues its mission, it is expected to reveal even more about the epoch of reionization and the formation of the first stars, galaxies, and black holes. Subsequent observations confirmed the existence of CS1019, but more detailed information remained elusive. The earliest light in the universe has shifted so far into the infrared part of the spectrum due to the universe's expansion that a powerful, dedicated infrared instrument like JWST is necessary to probe it effectively. So when JWST came along, CS1019, the brightest of the Hubble galaxies from this epoch, was an obvious target. The telescope stared at the galaxy for just 1 hour with all of its instruments but returned a wealth of data. In that hour, it was kind of like, wow, look at everything we can see with JWST. We've seen this whole portion of the spectrum of this galaxy and any galaxies early on in the universe we've never seen before, said astrophysicist Rebecca Larson. I was just overwhelmed by the amount of information, but then something she wasn't quite expecting. In addition to the light of star formation, there was a broad emission feature usually associated with AGN. When she mentioned it to some AGN researchers, things started to get interesting. Typically, a galaxy in the early universe emits either light from an AGN or light from star formation. To see both in the same galaxy was extremely unexpected, Larson said. There is some impact that the black hole is having on the emission lines that we're seeing, but most of what we see in our images is still dominated by the star-forming part of the galaxy. That a supermassive black hole existed more than 13.2 billion years ago and was seen growing is not as surprising as you might think. Much larger black holes have been detected in the early universe. Scientists still do not know how the black holes in those galaxies got to be so massive that early on in the universe. Now, with the discovery of this black hole only some 500 million years after the birth of the universe, it is a mystery in itself. The image of the early universe is changing faster than we expected, and like it or not, it is time to get back to the drawing board.